Okay, good morning. This is Subodh Pandey, as you know, and we are floating in the world of physics. These all things you know very well. Now today we are going to start a new topic that comes under the topic of the refraction. And in this lecture we will learn how a prism is actively participate to the phenomena of refraction. So I believe that you know the prism very well. Prism is basically made of glass and look like a triangular shape. So if we talk about basically symbolic diagram, then we can say that prism is only represented by a simple triangle, as you can see here in the diagram. So in the diagram, as you can see that there are three vertices are there, that A, B and C. That's why the named as ABC. Okay. So here uh, if the incident ray, as you can see here, from the point P, the incident ray starts, and firstly it hit to the interface AB. So AB is your interface, and the ray coming from the object hit at point Q. So it means we can simply say that AB is a interface, or we can say the refracting surface. So firstly AB represents the refracting surface. Okay. Now you can see that here the medium will be suppose air, and suppose this is made of glass. It is a glass frame. So in this case the ray is moving from rarer medium to optically denser medium. Okay, so it means the ray will bend towards the normal, and you can see this is your normal. So light bends like this way, and it takes a new path here. Firstly we will rough this one, and then we move further. So this is your the new path which is adopted by the refracted ray. Okay. Now what the ray refracted ray means the ray which is refracted by the interface AB. Okay, so this ray basically comes and again strike at point R, and the interface is AC. Okay, so here you can see that AC represent the refracting surface. So here are two refracting surface basically. First is your AB, means the ray comes and strike on it, and after refraction it strike on the other interface AC. So in short we can simply say that here refraction takes place minimum 2 times. Okay, it may be 3 times, but in that case of TIR. Here we are not including TIR, that's why we are simply saying that refraction through prism. So refraction through prism means whatever interface comes in the path of the ray, that must go on. Okay, so here AB and AC are the two refracting surfaces, or we can say interfaces, through which the light refracted. So this is the first basic thing you should know, and I believe that this is clear. Now what? The light, as I have told you, that the light goes from the optically denser medium. Optically denser medium means air, to optically rarer medium means glass. So if the angle of incidence R dash is not greater than the critical angle, so this is the condition. That's why I am saying that if there is no TIR, then only we can simply say the ray is refracted in air along RS. RS means the uh, the front interface, you can simply say. Okay, so the angle of refraction be I dash. The angle I dash is also called the angle of emergence. So what does it mean? It means because as I have told you that there are two interfaces, two refracting surfaces. First one is AB, this one your AB, and second is AC. So this is your first interface, this is your second interface. So light refracted from first interface, then refracted by second interface, and finally this ray will emerges out. So the name of this ray can be written as emergent ray, and whatever angle it makes from the normal, that is the angle of emergence. So I hope that this terminology is now clear to all of you. Now the angle UTS, and that is the angle of deviation. Up to here we have came to know that there are two refracting surfaces. Now the logic is why there are two refracting surfaces. That is due to the configuration of the prism. Okay, now what is the result of two interfaces? The result is that the ray will be, ray means the emergent ray. The emergent ray will deviated by some certain angle. This is the unique feature of the prism. So here you can see that in the diagram, the incident ray, this one ray comes and like this way and this way and this way, and this is the emergent ray like this way, this way and this way and this way. So this is your angle, and that is simply represented by delta and called the angle of deviation. Okay, so once again I am drawing a new diagram for you that you can easily understand. This is, let's suppose we have a triangle like this way. Triangle is prism, and a ray, this is your incident ray, and anyhow this is your emergent ray. So if we increase the incident ray like this way and just try to meet the emergent ray back to the incident ray, so whatever angle we get, that is the angle of deviation. So this is the unique feature of the glass prism. So glass prism basically refracted any ray, but in such a manner that the ray will be deviated by certain angle. And this is also useful for the formation of the spectrum also, because we will discuss later on that how the rainbow is formed. So in that time I will once again remind you that the same concept is in case of prism. So basically I will focus on that thing, that you should very clear that if there are two interfaces which are not parallel to each other, clear? So if we take a glass slab, suppose we have a glass slab, then in that case we can say that it will not deviate, but it becomes parallel to each other. But in case of prism, because the interfaces are not parallel to each other, that's why the ray, whatever ray comes out from the prism and what the ray is incident on the prism, that rays must be at the certain angle, and that is the angle of deviation. I hope that this thing is now clear. Now we will discuss about the complete derivation for you, and that is the refraction through a glass prism. So firstly, what we have learned up to, we have learned that there are certain angle of incidence which is represented by I, the certain angle of refraction that is represented by R, and these two angles are represented on interface AB, means on the first interface. Now similarly the R dash and the E, So these two are, we can say, represented by, this is your I dash. So we can write here I dash also. So there is no problem. Firstly we will rough it and then we will write like this. So I dash. So these two are for the interface, that is AC. Now these two are symbols. You know very well that I is used for the angle of incidence and R is used for angle of refraction. But here in this case I and R, this I is angle of incidence, no doubt. This R is angle of refraction, no doubt. But here R dash is the angle of incidence for the interface AC, and I dash is the angle of emergence in case of interface AC. So this is the unique symbols, and I think that there is no difficulty in front of you. You can assume any symbol, but I and R is basically the standard symbol taken as for the angle of incidence and the angle of refraction. That's why we have chosen here I, R, I dash, R dash. Okay. Now what? As I have told you that in case of prism, because the interfaces are not parallel to each other, that's why the ray bend by certain angle. And if there is a bending only, it means we are totally focused on the bending or the deviation of the incident ray. It means anyhow we have to come to the angle of deviation. And starting is point is your refraction. It means we should start from the Snell's law, because when there is a refraction we start from Snell's law. And in case of prism, because there are no we can simply say that we have interfaces which are not parallel to each other, it means the rays are bending by a certain angle, so it must be include some angle of deviation. So finally we can realize that we have an expression in case of prism that must have Snell's law, which is followed by the angle of prism, we can say, which is followed by angle of deviation. So how we can solve it, how we can get that expression? So firstly we will start from the Snell's law, and we will try to generalize it in the very easy pattern. We can simply say that what should be the pattern. Pattern will be like this way. We can simply write that the refractive index, according to Snell's law, as you know, refractive index, that is given by sine I over sine R. So it is clear that mu equals sine I upon sine R. There is no problem. That is quite easy. Okay. Now anyhow, if we want to calculate the value of I and R by simple geometry, then what should we do? Let's focus on the point Q. If we see that there are two rays, or here in case we can simply take two lines, okay, and this is your point Q, and one side this is your angle I, and one ray, this one is passing like this way, and this is your Q, and we can simply say that this is your point R. This is your angle small r, and we want to focus on the point Q. As we can see here that the two lines are crossed to each other. It means whatever angle will be this one, that must be to the angle of this one also. Okay, it means if this point represent capital T, as you can see in the diagram, so we have angle T Q R and plus small r, and that must be equal to I. I hope that there is no problem. So the value of I comes in terms of value of small r, and one more angle is there, that is your angle T, Q and R. Okay. Now come to the other point, that is your point R. So similarly you can see these are the two rays which are crossing to each other. This is your point R, and a ray is coming from like this way from point Q, and this is your angle R dash, and this is your angle I dash. So the same concept here also, that point is your capital T, as you can see. So if this is angle I, so this must sorry, I dash, so this must be I dash. Okay, it means you can once again write that angle your TRQ plus R dash, and this must be I dash. Okay, so if we totally focused on the 2 points, one is your Q and other is your R, then we have two angles, and one angle is your this one, or we can say that angle TQR, and the other one is your angle TRQ, and this is your TQR, and this is your TRQ. Now what if we add these two angles? So firstly we will rough this one, and then we will write that if we add two angles, angle TQR and plus angle TRQ, and that must be angle of deviation. There is no doubt, I suppose, because the exterior angle is always equal to the front to interior angle, sum of. Okay, so now put the value of angle TQR. Let's suppose this be question 1, this be question 2. So we can easily calculate the value of angle TQR and angle TRQ, and we can place here, then we can simply write that this will be I minus small r, and plus this will be I dash minus R dash. Okay, and that will be delta. So this thing is now clear to all of you, and I have already told you that we have to calculate the value of I and R, so that we can put the value of I and R in the Snell's law, which is written here only. Now what? We can rearrange it, and we can write that this is I plus I dash, and minus times R plus R dash, and that will be delta, and let be equation number 3. Now we will focus on R plus R dash, because firstly we have focused on the points of the interfaces, the point Q and R, and anyhow we managed to calculate the angle of deviation in terms of the angle TQR and TRP. But now here we can simply say that we have a new expression that is in terms of R plus R dash. So now if we focus on R plus R dash, so simply we can write, if we take a triangle, and that is your triangle QVR, this one, okay, this one, this and this, clear? So this triangle if we take, then we can simply write that R plus R dash plus angle V, and that will be 180 degree, because the sum of the three angles in any triangle is always 180 degree. So here we can write that R plus R dash, and that must be 180 minus angle V. Now, is there any other method to calculate the value of R plus R dash or angle V? Yes, definitely there is a method, and that is the angle of prism. If we see a cyclic quadrilateral is there, and that is A Q V R. This is a cyclic quadrilateral, so we can simply write that A means angle of prism, and plus angle V, A plus angle V, and that also 180 degree. It means A must be equal to 180 degree minus angle V. Now if it be equation 4 and it be equation 5, then equation 4 and 5 gives a result that R plus R dash is equal to capital A. Okay, so let rough it simply, and from 4 and 5 equation we have to write R plus R dash, that is your capital A. So we can write here, so R plus R dash, that is capital A, as we came to know. Okay, now what? We can simply put the value of R plus R dash as capital A. So we have I plus I dash, and that minus capital A, and that will be delta. Let me, this is equation number 6. Now we have no idea that how we can calculate the value of R dash and I dash, because if anyhow we can write that R dash is equal to R, then it may be 2R, and we can easily calculate the value of R. If anyhow we can write the value of I dash equal I, it means it may be 2I, and we can easily calculate the value of I here. But how we can say that I is equal to I dash and R is equal to R dash? So for it we have to go through the practical of the prism. So when we do the experiment in the lab, then we found a graph like this way. This is a graph which is between angle of deviation with respect to angle of incidence. So angle of incidence and angle of deviation in case of prism have a unique graph, that is a U-shaped graph. That is not absolutely U-shaped, but we can say that slightly there is a curve. Okay, so there is a point at the bottom, we can simply say bottom of the graph, and if we see at this point, then this is your minimum deviation, or we can say angle of minimum deviation. And if we see here, then I is equal to I dash and E equal to E dash. So problem is solved. Anyhow we have to write that R must be equal to R dash and I must be equal to I dash, and the problem is solved by our experiment. Our experiment indicates that if the angle is minimum, the angle of deviation is minimum, then at that condition I will be equal to I dash and R will be equal to R dash. So with the help of this experiment we can write a result. So what result we came to know? That we write simply, if this is a condition, means we have performed, we have to go through the experiment of the prism, and on the behalf of this we conclude, or we can simply write so that no one can deny it. And what we write that if delta is equal to delta m, means angle of deviation will be equal to angle of minimum deviation, then only then R must be R dash and I must be equal to I dash. So here we have R plus R dash equal to capital A. So this is your equation number 5. Let be. So with these three observations what comes from the experiment. These observations can be used in equation number 5 and 6. And then from equation 5 we have r plus r, because in place of r dash we can write r, and that will be a. So r will be nothing but a by 2. This is your first result. And here from equation number 6 we have I plus I, that will be delta m. In place of delta we have delta m plus capital A, so we can write that I, that will be equal to delta m plus a by 2. So here we get the final value of angle of incidence and the angle of refraction what we are in need of. So what is the problem? Now put the value of I and R in the Snell's law and you will see your desired result. And the desired result means Snell's law which comes after the prism, and that is your mu or eta, whatever you can write, mu equal sine I is delta m plus a divided by 2 upon sine r. So r is a by 2. So this is your golden result or the final result in case of glass prism. Okay, so I hope that this derivation is clear. Now what? There is one more condition is there. If it is said that the prism is thin or angle of prism is thin, simply if angle of prism is thin, then what should we write? Then we can simply say that if the angles are small, then sine and tan can be neglected easily. It means if we have sine theta, then we can simply write that it is a theta. So this formula can be modified like this way. So we can write mu, that is equal delta m plus a by 2, and that one divided by a by 2. It means sine can be neglected in case of thin prism or angle of prism is thin. And here 2 cancel out, and we have simply delta m, that is equal to firstly we have to rough it, and then we write the result here, and result is delta m, that is equal mu minus 1 times capital A. So when we solve it, then we get the result like this one. So this is the another interesting result in case of thin prism or the angle of prism is thin. So there are two derivations. This is your generalized derivation or generalized formula in case of refraction through glass prism, whereas the other one is applicable only for the thin prism or the angle of prism is thin. So I hope and I believe that this lecture is now clear to all of you. Okay. Now this is your question, because I have discussed the derivation in front of you. So we have come here for the numerical. As you can say that the angle of minimum deviation for prism is 37 degree, it is given. It means the delta is given, that is 37 degree. If the angle of prism is 53 degree, so angle of prism means capital A, that is 53 degree, and that is also given to you. Find the refractive index of the material. So refractive index, basically you have formula sine delta m plus a by 2 and divided by sine a by 2. This is your basic formula you go through. Now what we have to place the values here, so we come sine delta m, and that is, you can write that is, this is delta m. Okay, delta m 37 degree. So 37 degree plus a, that is 53 degree, and whole divided by 2, and that is sine a is your again 53 degree divided by 2. Okay, now you can solve this. What we get? So firstly we will rough it. Okay, so here we can simply write down that will be your sine mu, mu equal sine, and that will be your that is your 37 degree plus 53 degree by 2, and divided by sine 53 degree by 2. Okay, so it will be sine, and so 90 by 2 means we can simply write 45. Okay, so it will be sine 45 degree, and divided by, this will be sine, and 53 divided by 2, it means 2 to the 4, and 6.5. Okay, so sine 45 and sine 26.5. So when we put these values, then we get the answer, that is 1.5 approx. 1.5 or 1.58 may be clear. So this will be your final answer. I hope and I believe that this question is now clear to all of you. And as I have already told you that if you want to learn the physics, then there is not a single way that you just cramp it, but you have to explore it. How much you can explore the topics, how much you can realize the topic, how you can experience the topic, the same pattern will be followed by your mind also. And once your mind is explored, so in that case you will be a genius in physics. So try to explore each and every topic within your mind, and try to we can say resolve any numerical within yourself. Firstly try yourself, and if you feel any problem, then go through this video. In case of numericals, once you have go through the derivations, you go through the conceptual problem, then I think and I suppose then should be no delay or lagging between the numericals and the concepts. So thanks for watching me, thanks for listening me. Okay, so keep in touch with me, and enjoy your journey of physics. Thank you very much.